how are you? I hope that all of you are safe and healthy. Don't worry about me, I am very well, I'm fine. Now let's have our new lesson. I am very excited to teach you now. Our lesson for today is about what? Again, it's still the continuation of our lesson about the law of inertia. Okay? Now, let's get started. For our lesson, I want all of you to show me 3 things. First, what you already know. Second, what you want to know. And third is what you have already learned. Let's start. First, what do you know? First question, he developed the 3 laws of motion, which became the foundation of modern physics. A. Aristotle. B. Galileo. C. Gregor Mendel. Or D. Isaac Newton. Think. Number 2. The question is, Newton's first law is popularly known as law of blank. A. Acceleration. B. Inertia. C. Reaction. Or D. Unknown. Number 3. Complete Newton's first law of motion. Fill in the blanks. Second blank. Third blank. Fourth blank. Fifth blank. Sixth blank. Wow, very good. Very good, children. Now, because I already know what you know, let's continue to what you want to learn. Okay? Objectives for today's lessons. First, for you to sign and define inertia. Second, is for you to identify the relationship between mass and inertia. Third is for you to differentiate mass and weight. So imagine this. You are riding a jeepney. Do you know what a jeep is? Okay, like this. You're riding like this. If the driver step on the brakes and suddenly stop, oh, have you experienced that? I want to know what you have experienced if the driver stopped the jeepney. Imagine you are riding on a bus, or have you experienced riding a bus? Who experienced? Yeah, I've experienced it already, but sometimes I stand on the bus. I stand like this on the bus. If the bus is already full, you have to stand like this. And then the driver suddenly stops the bus and you will feel this, like that on the picture. Have you experienced that? So see, if you are riding in a bus, you would be like this. But if the bus driver suddenly stops, you would do this. Have you felt like this before? That is a definition by the law of inertia. Later, I will teach you more about it. I would explain to you. The question is, how can we sign inertia? You know? Do you know? Inertia. Inertia. Inertia is signed like mass or weight. Second, how can we define inertia? Inertia is the tendency of an object to resist changes in motion. What does it mean? If the object is at rest, the object would want to stay at rest. Look at the picture of the rock. It's at rest, right? The rocks are at rest. See? So if you try to move it with a small force, then it would be hard to move that rock because it would resist the change in motion because it's at rest. Like you, when you're sleeping at the house, you'll be like this, and then your mom would call you, and she would be calling you again. You would be like this. Your body would want to stay at rest. Your body would like to stay at rest. It doesn't want to move because you don't want to wake up. It's so hard to wake up. Your mom would call you again and again. You would be like this. It's so hard. Why? Because of the law of inertia. Now, if an object is moving, it will stay moving. It would like to stay moving. Example, do you see this? It would be hard to stop a moving object. Why? Because of its motion. If it's moving, it would want to stay at rest. It doesn't want to be disturbed. Understood? Now we also have an external force, which means what? It's another force that would disturb or change motion. So that means if an object is at rest and if you disturb it, like this mouse, it's at rest and I disturb it, it's at rest. Can you see that it's stressed? It's not moving. See, I'm disturbing it, but it doesn't really want to move like that much. But I can move it like this. And what am I doing to the mouse? I am disturbing the mouse. I am giving another force that will disturb the mouse. But if no one would disturb the mouse and it stays like that, I will just wait for it. Like, will it move? What happens to the mouse? It stays at rest. Why? Because there is no other force that would disturb it. See? You understand? I hope it's clear. Okay. Another example. Do you know a fan? Yeah, a spinning fan. Like that. It spins, right? It would continue moving. Moving and moving and moving. You know the fan, right? Yeah, it will continue moving. Continue moving. But how would it stop? It would stop if you switch it off or you play it like a kid, like this kid. The oh, and then he would try to fit his finger on the fan, and then the fan would stop moving. Now let's watch this video about cup and peso experiment.
Newton's first law of inertia states an object at rest stays at rest and an object in motion will stay in motion with the same speed in the same direction unless acted upon by an unbalanced force. Objects tend to resist changes in their state of motion. This tendency to resist changes in their motion is what we know and describe as inertia. This is one of many experiments to prove inertia. I am going to do the coin in the cup demonstration. For this, you will need a glass, an index card, and a few quarters. It works with more than just one quarter. Whilst the coins were on top of the card, they were at rest. The reasons the coin fell vertically and not horizontally is because there was no friction between the card and the coins, but also because there was no horizontal force carrying it that way. Gravity, the outside force, was what made the coins fall into the glass. If we did this experiment with an eraser or something that had a lot more friction than the coins, then the outcomes would be severely different. As I said before, this is only one of many different experiments to prove inertia and Newton's first law of inertia, of how it works and why. Thank you for watching my demonstration on inertia. I hope this helped, and goodbye.